Welcome. This is part one of a two-part series on rate of change and slope, and today we're going to work with rate of change. We can investigate rates of change. We can determine what the change in the dependent variable or the output is to the rate of change in the independent variable or their input. Knowing that if you think of this as a machine, the input is what you put into it, and the output is what you get from it. And so the input is your x values, and the output is your y values. Our example is Eve keeps a record of the number of lawns that she has mowed and the amount of money she has earned. Tell whether the rates of change are constant or variable. And remember that constant means it's the same each time, she doesn't change. The variable means there's some change. So in this table we have the number of lawns and the amount that she earned. So on day one she mowed 1 yard and she got $15. On day two she mowed 3 lawns, she's gotten $45. On day 3 she mowed 6 lawns and has $90, and on day 4 she mowed 8 lawns and has $120. So what we're looking at is to determine whether or not this was a constant rate of change or a variable change of rate. So let's first identify our input and output variables. Input is your x value. That's the number of lawns. So that's our x value. Our output is how much she earned. So that's going to be the money earned. And so that's going to be your y. In order to find the rate of change, it's a ratio and it's over time. So we're going to find the difference in those times and use that information to determine if it's a constant or a variable. All right, so we have day 1 to day 2. And so we're going to start with day 2 and our y over x. So we're going to take 45 minus 15, and that's going to give us 30. And then we have 3 minus 1, which gives us 2. 15 divided by 2, or sorry, 30 divided by 2 is 15. Then we have day 2 to day 3. So y is over x, so y is first. So we're going to 90 minus 45. And 6 minus 3. Well, 90 minus 45 is 45. And 6 minus 3 is 3. 45 divided by 3 is 15. The next one is day 3 to day 4. So on day 4 it was $120, so we're going to take 120 minus 90, and that's 30. And then we're going to take 8 minus 6, and that's 2. 30 divided by 2 is 15. So let's take a look. Do we have a constant? Are they all the same? Yes, they are. So we have a constant. So the rate of change is constant. And it is constant at $15 per lawn. Your turn number 1. It says the table shows the approximate height of a football after it is kicked. Tell whether the rates of change are constant or variable. And the first thing they want us to do is to find the rates of change. So we need to find the difference between two different ones. So we have, say we pick these two. We're going to have 18 minus 0. Here's my x's, here's my y's. Over 0 minus 0. And we get 18 over 0, which is 0. Okay? Then we have, let's try these two. So we're going to have 31 minus 18 over 1.5 minus half. 31 minus 18 is 13, and that's going to equal 13. And then we have these two. If we take 26 minus 31 over 2 minus 1.5, 2 minus 1.5, we get 0.5, and 26 minus 31, that's going to give me a negative 5. And if I take negative 5 and divide it by 0.5, I get negative 100. No, 10. Sorry, 10. So take a look at our y divided by x. Do we have a constant or do we have a variable? We have a variable because each one is different. Okay. We can also use a graph to find rates of change. We can take a look at the line and find points on the line. And for every point, we can write down the ordered pair. And then we can use the x and y's in our ordered pairs. And remember, x and y in our ordered pairs. So from 1 to 2 hours, so that's going to be these two dots right here. Our y's are 30 minus 15. And 2 hours minus 1 hour. So that's 15 over 1, which is 15 miles per hour. From 1 to 4 hours, they're talking about this one and this one. So we have 60 minus 15. And we have 4 minus 1. That's 3. 60 minus 15 is 45. 45 divided by 3 is 15 miles per hour. And then find the rate of change from 2 to 4 hours, so that we're looking at this one and this one. So we have 60 minus 30 and 4 minus 2. That's 30. That's 2. 30 divided by 2 is 15. Now that we've tried several of them, do we have a constant? Yes, we do. We have a constant, so therefore we do have a proportional relationship here. There is a proportional relationship between Nathan's time and the distance. If you have any questions, please talk to your teacher.